Hey guys, welcome back. This is a video mostly review. We're going to talk a little bit more in detail about isotopes than you've probably heard before. But this is just about what makes up an atom and what an isotope is, basically. So it should all be pretty much a review from your other science classes. So you should know already that protons are positively charged portion of the nucleus. Neutrons are also a portion of the nucleus, but they contain no charge. So protons are positive. Neutrons are no charge. They're both in the nucleus. So that's what's in here. This is your nucleus. Protons and neutrons. Electrons are very light, negatively charged. We talked about this in the last video with Thomson's experiment. But they're negatively charged, and they are found outside of the nucleus. So all these little guys out here are electrons. Whatever. Okay, now here's a big important statement right here. That doesn't look very important, but it is. Atoms are always considered neutral. So write that in there. Meaning that they always have the same number of protons and electrons. If you understand that right now, that makes your life substantially easier for the rest of the year. You know, these last three are all very similar, but completely different at the same time. So the atomic number is simply the number of protons found in the nucleus of the atom. And then the next statement is very profound as well. It defines one element from another. So if you look at your periodic table, the difference between hydrogen and helium is 1 proton. The difference between hydrogen and lithium is 2 protons. If we add another proton to lithium, it becomes beryllium. That's how we know what element is which element, is by the number of protons it has. You see how every element has its one different atomic number than the ones beside it. Now the mass number is the number of protons plus neutrons found in the nucleus. So protons plus neutrons, we do P plus N. This is also used to define isotopes. Because remember, we can't change the number of protons because that changes the element. But we can add and remove neutrons as we deem fit. That's why we were talking about the last video, Dalton's proposal, where he says all atoms of all elements are the same, or all atoms of the same element are the same. This is why it was wrong. They can have different numbers of neutrons. Now the atomic mass, this one's special. We talk more about this in the next video, but it's the average of all the isotopes of that element weighted by the percentage of abundance. That doesn't make a whole lot of sense to you right now. It will in the next video, but it is the average of all the masses. Next one, isotopes. What are isotopes? We've talked about this a couple of times before. They're changes in the number of neutrons, hence the mass number. So they're changing the number of neutrons, which affects the mass number. So we come down here, we've got 3 different carbon isotopes. They're all carbon because they all have 6 protons. See, carbon-12 has 6 protons. Carbon-13, 6 protons. Carbon-14, 6 protons. If it didn't have 6 protons, it wouldn't be carbon. Okay. Now the difference comes with a mass number. Carbon-12 has 6 neutrons. 6 plus 6 equals 12, which is where this number comes from. We talk about that later on in the year as well. Carbon-13 has 1 more neutron, so 6 plus 7 is 13. That's where its name comes from, 6 plus 7. And carbon-14, obviously we added another neutron. Okay, so this little dash is the mass number, which is protons plus neutrons. Something you should go ahead and learn right off the bat. So now here's your practice. Most of these you should be able to know. What is the difference between mass number and atomic mass? Mass number, what we just talked about, is protons plus neutrons. Atomic mass is the average of all the masses. Keep those separate in your mind. They are completely different. Sometimes they turn out to be the same. Most of the time they're different. How is the mass number calculated? We just talked about it. Protons plus neutrons. Obviously, that's important since we asked it twice in a row. Where can the atomic mass be found? Periodic table. It's right beneath the element. How many protons are in sodium, and how do you know? Well, let's look at the atomic number, which is on the periodic table. Sodium is in A, in case you're confused. That's in A. And its atomic number is 11. So we have 11 protons. All this is found on the periodic table. How many electrons does calcium have? Well, we know it's neutral, so that's where we get. Remember, we always consider atoms neutral unless we tell you differently. So its atomic number equals 20. So 20 electrons. You'll be doing a lot of these types of questions, so if you've got questions, go ahead and write them to the side, and I'll fix you in class. What happens if the atomic number changes? Different element. It becomes different element. Okay. How many neutrons are in uranium-235? Remember, 235 is the mass number. This is protons plus neutrons. If we look at uranium on the periodic table, it's kind of hard to find. It's number 92. So this is number 92. So that's how many protons we have. We do 235 minus number of protons to equal number of neutrons. So it equals 143 neutrons. All right, what is the identity of an element with 3 protons, 4 neutrons, and 3 electrons? It gives you a lot more information than you need. If we're just looking for the identity, we just look at the protons. There's 3, and the atomic number of 3 is lithium. Now you could go on and get the mass number, and you could go 4 protons plus 3 neutrons equals 7 neutrons. You can make this even more specific and say lithium 7 if you wanted to. So at the hyphen notation element 8, we just did that. Ha! Lithium 7. So I'm just going to do this. You can write ditto as long as you know what you're talking about. Hyphen notation is element hyphen mass numbers. So I'll write that down here if you want. Element hyphen mass number. Okay. And there we go. That's all we got.